Welcome to the College of Engineering virtual brown bag session, where every Friday we dive into an interesting and exciting topic for you to learn about. Hi, I'm JG McLaughlin, and we'll host today's session. This Friday is our alumni spotlight session, and we're going to introduce to you a UTA alum who is doing some really unique work in the world of aerospace engineering. I'll introduce our guest who will talk a little bit about her journey, what she's doing now, and then we'll open it up to a few questions from you and our audience, and if you could use the Q&A feature on Teams Live to do that. So today I have the distinct pleasure of bringing to you Dr. Wendy Okolo, and she is a two-time Maverick engineer, attaining her BS in 2010 and her PhD in 2015, both in aerospace engineering. And today she's an aerospace engineering researcher with NASA Ames, where her focus is in the area of systems health monitoring, control systems design with applications to air and space components, vehicles, and systems. She manages a multi-million-dollar sub-project on a system-wide safety project, leading a team to develop the monitoring, predictive, and mitigation capabilities that will enable the safe operations of unmanned aerial vehicles in the U.S. national airspace. She also leads a controls team on a space technology project to advance the guidance, navigation, and control technologies that will make precision landing for deployable entry vehicles a reality for our planetary exploration. Her research experiences also include stints at the Air Force Research Laboratory at Wright-Patterson Air Force Base and at the Advanced Development Programs of Lockheed Martin Skunk Works. At the age of 26 years old, Dr. Akolo became the first Black woman to obtain a PhD in aerospace engineering from right here at the University of Texas at Arlington. Dr. Akolo is also the recipient of the 2019 NASA Ames Early Career Researcher Award, the 2019 UT Arlington Distinguished Recent Graduate Award, the 2019 Woman in Aerospace Award for Initiative, Inspiration, and Impact, and the 2019 Black Engineer Year of the Award for the Most Promising Engineer in the U.S. government. She's accomplished. Dr. Akolo, you're a dynamic trailblazer. Thank you for joining us today, and welcome to the Virtual Brown Bag Series.
Thank you, and thanks for the warm introduction. It's always a good thing to be back virtual. It's virtual in this situation and doing stuff with my alma mater, University of Texas at Arlington. I'm happy to be here, and if you say I'm good to go, I can go ahead and get started.
Absolutely. I know you have some great information to share about your journey and things you're doing now with our audience today. So I'll step back and let you start. Welcome, Dr. Akolo.
Awesome. Thank you. So I'm Wendy, and today I'll just kind of give an overview of what my journey was, starting out at UTA, through undergrad, on to grad school, now that I'm at NASA, and what kind of things I do now, and just, with some information about the kind of projects that I've worked on, a few tips and tricks for the students that may be on the call. And then there'll be some opportunity for Q&A at the end. So keep those questions and feel free to jump in and ask at the very end. Yeah, I started at UTA in 2006, and I was an undergrad aerospace engineer. I lived in Arlington. Some of you may be familiar with it. And it's just, small, perfect space for, your bed, your study table. And I remember fusing my study table with my bed. I have this picture here just so, it was more aesthetically pleasing to me and I have more space. And I put this picture up on Facebook, 2007 maybe? I don't remember, years ago. And someone left a comment under that picture. It's very funny. It says, someone is really into their books when their study table is fused with their bed. And I thought that was hilarious because I didn't do it intentionally to fuse my study table with my bed because I wanted to study. But I remember there were days I would actually from like a nap and just literally go from bed to the study table. That's it. I wouldn't get down and do anything. It would just be the bed to the study table. So for the College of Engineering undergrads that are on this call, you know what that's like, right? You can kind of relate. So in there, I think that's my physics textbook for my freshman or sophomore level physics class. That was an honors class. And I was a member of the Honors College, which I really loved. It was great. Smaller, and you got the opportunity for really kind of experiential hands-on learning with the students and the professor because of the smaller class sizes. So if you are in the Honors College, great. If you're not in the Honors College and your GPA is good enough, get in. For a College of Engineering, for engineering students, it's pretty amazing because they have classes that you have to take anyway for fulfilling your degree requirement. So it's not really great to work. So Arlington Hall did homework. I did a lot of homework. Engineering students can relate to that. You just get homework and homework and homework and more homework, and you're just doing homework over and over and over again. I spent a lot of time doing homework. I spent a lot of time getting books from libraries, and I say libraries plural, not just the UTA library. I was familiar with the libraries at other universities of my friends, even outside of the Dallas-Fort Worth area. My sister was in medical school at the time. I knew what her UTMB website looked like. I knew what that library interface looked like. And sometimes I'd see if they had a book that I needed to help me understand the material that I felt like I wasn't understanding clearly enough from my coursework or from my textbook or from the help that I had. And then I actually see my old little iPod in that corner. There was some great music on there. I need to find that iPod. If that's still, I don't know if anyone remembers these first generation iPods, but yeah, so I spent a lot of time, in the libraries, not really in the library, but getting books out of the library because we just had homework and homework and homework. And it's just a reminder that sometimes you don't get all the answers that you need from one source, right? The graduate students here will understand research, what you do. It's not enough to say, the material isn't sufficient or the coursework isn't enabling you to learn. The onus is on you to do what you can to understand the course material, and your professors in the college would just really be a guide. So I just wanted to throw that in there. So that was like freshman, sophomore year. I think a photo was taken, and in my sophomore year, I stumbled on, I don't know how I found this, Monster Diversity Leadership Programs. I don't know if it's still a thing now because this was like circa 2007. The Monster DLP program was really a way for to attend. It was like a career fair, kind of a student development program over maybe 2 to 3 days. I don't recall. But what was particularly interesting was that program, when I applied to it and attended, it was held at UTA. So we were actually housed at the University of Texas Arlington, right on campus, and we stayed in Arlington Hall as well. And when I attended that program, it was once, I don't know if it was during the fall, spring, or even the summer, so just note it and look it up. When I attended that program, I got to meet representatives from different companies. One of the heavy sponsors there was Lockheed Martin. To meet them, meet the recruiters. I even won a scholarship then. I think there was a scholarship for like engaged students throughout the couple of days that program was going on. And through that, I met those recruiters from Lockheed Martin, and through that I got the opportunity to do an internship my sophomore year. And this internship was on the Orion vehicle. You might be familiar with. It is NASA's kind of replacement for a crew vehicle that will take humans to low Earth orbit, and so this was located in Houston, so about 4 hours from UTA, the summer of 2008 and 2009, I believe. So I got 2008 the opportunity to go work on this Orion vehicle for Lockheed Martin, who was a contractor for NASA at the time, Johnson Space Center in the Houston area. And the first summer that I was there, I worked with the systems engineering team working on requirements. So as an undergrad, you don't know what systems engineering is, or you don't know what requirements are, right? But so internships kind of expose, give you that exposure to different things and what working in the real world really is, and how the coursework that you're taking, is applicable or not applicable, right, to the full hands-on data environment. And so the systems engineering team, the requirements management division, is basically keeping track. I was keeping track of requirements, making sure that people were updating the places, the databases that would store these requirements with the accurate information, or if there were any updates to be made, I would be making them and I'd be reaching out to people, the engineers, the developers, whoever the designers were for this vehicle. So they didn't like me very much, right? In that I would contact them and say, hey, this value is missing. Do you have this, or is there an update for saying, oh, the vehicle will maintain or have to withstand this much thermal temperatures, ambient conditions, or whatever it is that has been put in but has not been specified. So I keep track of those in the summer 2008. And then when I went back in 2009, because I had that experience, 2008 was easy. And bear in mind, I didn't even have to interview for these, because I had already built those relationships with the recruiters and then with my team the first year round. The next time around, I went back and I got to do something different on the vehicle as well. I worked with the mechanical design team, the hatch mechanisms, which is basically the doors of the vehicle. And they were doing the design and analysis. And so what I did was design in Pro-E. I don't know if there are any Pro-E AutoCAD people. So yeah, the Pro-E knowledge that I had from design graphics, which was like the first year mechanical engineering aerospace class, I used in my internship. I used that in my internship to design test fixtures for the hatches. So I actually designed in Pro-E the actual hatch, like a test fixture for it, and the actual door itself, such that we could build that and see that it could withstand vibrations and pressure and other kind of tests that needed to be done for this vehicle. So that was really, really cool, very amazing hands-on work that I got to do. So during this time, I was, still a student, 2009, 2008, like I said, involved on campus to some extent. I was a member of the African Students Organization, and I was on the dance team then. And at this point, I had become a resident assistant. In 2000, I became a resident assistant in one of the residence halls on campus, Untitled. And so still doing, school and maintaining some kind of extracurricular involvement as an outlet for me was very, very important, I'd say. So if, I just kind of want to encourage people here, even the non-students, to not forget, those outlets are important, right? Sometimes it's easy, especially with the pandemic, 2020, to just get so consumed in one thing or so focused. Some of us are still trying to achieve that work-life balance, but just making sure there's some sort of outlet that helps you reset, to refocus. For a lot of people, it's exercise. For some people, it's exercise. I'm one of those people, and it really, really, really is very helpful. For the students here that feel like, oh, they're stressed, they don't have time to do anything but schoolwork, try to find that outlet. If it's 30 minutes a day, if it's playing chess, do that. So my involvement as an RA and the African Students Organization and Society of Women Engineers, I was the president there, really helped me stay grounded, and I was able to maintain a very high GPA even while I was doing all of that. So I did those internships, and internships will really show you what you don't know, right? They'll show you how little you know. Here I was at the end of my undergraduate career, thinking it was going to be time to graduate really soon. I was like, oh my goodness, there's still so much to learn, right? Or, oh my goodness, I don't want to grow up, right? Growing up and getting a full-time job, and that's it, that's just it. Like my internships, I'd wake up early in the morning to try to beat traffic, to get to work at a decent enough time, to work for 8 hours, to leave work early enough at a decent time, to try to beat traffic, to get home early enough to make lunch for tomorrow and pack it and get a good night's rest, to wake up early enough to beat traffic. I was like, okay, this is monotonous. What else is out there? I wasn't ready, but I also really found a number of things interesting that I was like, oh, there's a lot of opportunity to learn and to grow. When you work with some really, really smart people during your internships, you realize, okay, there's still a lot out there, and a lot of them have gotten those experiences and knowledge from being on the job. But for me, I was like, okay, there's probably more I can learn within the four walls of the University of Texas at Arlington. So in my senior year, it was either first semester senior year or second semester junior year, I was taking controls. What was it? Flight dynamics, one of the controls. And I was taking controls with Dr. Attila Dogan, the Mechanical and Aerospace Engineering Department. Great class, right? I had taken flight dynamics with him and I loved it. And then I loved controls too. It was just such an amazing, fun class. And at some point during the class, he brought up this opportunity. He used to spend time in the summer at Wright-Patterson Air Force Base, Ohio, and was looking for a student that'd be interested in accompanying him on this opportunity. So he said, oh yeah, he's looking for a student that wants to do the and we have to be willing to be able to pass through whatever checks are needed. But it would start the summer of 2010. So this was fall 2009 that this opportunity came up. So summer 2010, that was about a year after. So when I heard this, when he told me, I was like, oh yeah. When he told the class, I went up to him at the end of class and said, I want to do this. I'm very interested. This sounds exciting. And the work was in aircraft formation flight as a fuel-saving method of flight, and I'll talk about that, in a bit. But I was like, yeah, I want to do this. And I started, my goodness, how am I gonna, beat out the competition to get this opportunity that I really wanted? But I did. I was very blessed, very grateful that I got that opportunity. So in the spring of 2010, we started to work together. He started to get me familiar with the simulation environment for the work that we were going to be doing in the summer of 2010. And there's a picture of me and Dr. Dogan. And on the left side, you can kind of see a bit of the simulation that we're working on. This photo was probably for a magazine. I don't know if it was the College of Engineering or the Shorthorn or something, but it's great because this was the relationship I had with Dr. Dogan, who then became my PhD advisor. Research really just opens you up to a lot of things, and you're working to solve and answer questions that haven't been answers that you don't know the answers to, or your advisor doesn't know the answers to, but working together, you're able to figure it out by reading papers, playing and building stuff, designing stuff, testing, validating, looking at what the plots are saying, and going back to to reassess. You have a hypothesis, you want to be able to explain the results of whatever it is you're saying. So that was spring 2010. Summer 2010, we both went to the Air Force Research Lab to start this work in aircraft formation flight. And the idea behind this is, kind of when you think about birds flying in a V formation during extended travel, right? They do that because the trailing birds don't need as much energy to fly. And the reason that's happening is that the ones behind, if you look at like that kind of V or staggered V formation, they're kind of surfing, if you think about it, they're surfing the vortices of the lead bird, right? Of whatever bird is in front of them, whatever the preceding bird is. They're kind of surfing those vortices and not requiring as much energy. So if you think about that same idea for planes, it's doable, right? So they don't need to be as close, but planes like birds, when they fly, because of that pressure differential, on the top of the wing and the bottom of the wing, there are those vortices that are generated and extend significantly far downstream that another vehicle can kind of take advantage of. There are these regions of upwash to the left and the right of the plane. So directly behind you have this kind of downwash region that if there's not enough controllability, the trailing vehicle shouldn't be directly behind. That's why the formations are like a V, like an inverted V, staggered formations. So in 2010, we started to do that work at the AFRL. I worked with the simulations that he had designed with prior students for aero refueling. So aero refueling is kind of similar because the plane is coming close enough. but we modified that simulation for formation flight use. And so we're using like a lead large KC-135 tanker vehicle, and then in the back like a delta wing bomber type vehicle, which was an EQ-2, just a fictional aircraft that was designed by the AFRL. It's not a fictional, it's a research aircraft rather, designed by the AFRL to demonstrate and represent the capabilities of a long-range tailless bomber type of aircraft. Actually showing with the data that we were able to create at the AFRL, what happens when the trail aircraft, which is that delta wing, goes in the downwash region where it's not supposed to for the lead aircraft, and if or how it loses controllability. So this is really cool, a really awesome project and great work to do that I continue to do it for my PhD. This became my PhD research focus and dissertation topic. And so I stayed on at UTA from 2010 all the way through 2015, pursuing my PhD and doing this work. We'd go back in the summers to the AFRL, conduct some more analysis, switch out the planes, and then actually started to look at alternative methods for trimming the vehicle. So when the trail aircraft is in this kind of off-wash region, a safe field doesn't need as much energy. Energy for our purposes could be considered as thrust and fuel savings, right? For birds, we're talking about energy with reduced drag. What reduced drag means is reduced thrust, and reduced thrust means reduced fuel, and so you can save money. So you have this fuel savings, and you are basically obtaining this fuel savings, but then you have these induced, particularly roll moments on the vehicle that you now have to trim out. And so you're basically now having to use your drag-inducing control surface effectors that could cause you more drag. So how else can you trim this vehicle? So that's one of the things I really spent my time doing. How else can you trim the vehicle without using your ailerons, rudder, and elevator as much? So we looked at differential thrusting. So moving fuel from one side of the vehicle to another side to generate roll moment. Differential thrusting, using more thrust on one side and then the other side to generate a yaw. So internal fuel transfer and differential thrusting are shown to provide even more benefits of flying information, because then you're not using your typical control surfaces. So I spent all of that time doing this really cool work with my advisor, going to the AFRL in the 2010, 2011, and 2012. While doing my PhD work full time, which was this, but then we'd go to the AFRL, I'd get the opportunity to work with the aerodynamics, generating all this data for different aircraft for our purposes, and it's amazing the amount of research you can get done in the summers when you don't have to deal with classes, right? You can get a lot done when you're working, even like 8 to 5, you're just there, focused, really focused enough without the distractions of like a project here or homework there or attending class. These things break up your day and can take time from research, but these are necessary, very necessary, important things that you need to know. So I got a lot done, published a lot of papers during that time, and then I come back to school and focus on coursework and everything. So my final year in grad school, I don't know if many of you might know this vehicle. There were a few people that were obsessed with the SR-71 Blackbird, and we'll talk about it and how books have been written about this vehicle. But one of the things that you would not, if you know the SR-71 Blackbird, then you know that it was a Lockheed Martin kind of developed spy plane, if you want to call it that. And there's a whole history and story behind it. So if you know SR-71 and you know Lockheed Martin Skunk Works, Lockheed Martin Skunk Works is a big deal, right? The primary advanced programs of the Lockheed Martin organization built this plane. So my last year in grad school, so about 2014, I got the opportunity to work with the Lockheed Martin Skunk Works team in Fort Worth. And this was also through my advisor, who had another student that was a full-time employee of Lockheed Martin while he was also pursuing his PhD, Chris Elliott, and he knew the manager, and there was an opportunity for me to come do some work with them, and possibly even start on there. So I went there, I was working there and also going to school for, I think, throughout the fall and a couple of months semester. And so it was intense. I was very busy. Imagine trying to complete a dissertation and also working at Lockett. Funny story, when I was still at the AFRL in the summers, PhD students here, you know about qualifiers, right? And professors know about quals as well. Quals are very interesting. Your qualifying exams for your PhDs, because you get into the PhD program and you think you're in the PhD program. It's very funny, but you're not. Right, you start at coursework, you're doing all this stuff, and then 2 years in, someone hits you with a boom. You have to take qualifying exams. I mean, you know beforehand, but like, oh, all of a sudden you have to take these qualifying exams to take you from being a PhD candidate to being a PhD student. And you can only there are only so many tries for you to pass the quals before you. Like you can only take the calls so many times, and then you have to find another institution. You have to leave, or you just can't be there taking calls. And calls test you over things that sometimes PhD level, graduate level work, but a lot of times undergraduate level work, because it's basically showing that you understand the undergraduate level material well enough to conduct a PhD. You need to be capable of research how to do. So I remember when the first time I took the calls, I was at the AFRL working, and I literally, studying for calls in my evenings and weekends, working full-time 8 to 5 at Wright-Patterson. And I remember taking the calls because I couldn't go back to school. It was the summer. I couldn't go back to school, take the calls. I remember taking the calls in my cubicle. Dr. Dogan was, in another cubicle right there, and they sent him the questions for the areas that I had chosen. He was sent those questions. He gave them to me. I was timed. I took the calls, submitted. I finished everything, and then I give it back to him and went back to my cubicle to go to work. I literally just took an exam, submitted it, and just went back to work. There's no breaks, no time. There's no, we're here for a reason. We had 12 weeks. We had to get stuff done. So. It can get intense, but it was also very fulfilling work. So again, this was another intense but fulfilling thing that I got to do. Drive from Arlington to Fort Worth every day. I believe it was every day. I don't think it was part-time. Yeah, I believe it was every. I don't recall, but I drive there and work on this. And this is a picture of the F-35C. Really, really cool. Very, very fuel optimized vehicle. And what we were doing was looking for additional savings from when this vehicle flies. If you look at the, kind of the control surfaces, the flaps, the back, there are multiple, there's multiple surfaces, these flaps that when they deflect, to basically trying to answer the question of how more optimally can we deflect those flaps such that we don't have as much drag on the vehicle. So we have less drag on the vehicle, right? And can get some fuel savings. So if you look at that bowl of how optimal you can get, it was pretty shallow because this vehicle was really, really, really optimized for fuel. But even like 0.5% makes a difference, right, with fuel savings. So it was really cool work we got to do. I used the peak seeking algorithm developed by people at NASA, I believe, and applied it to this vehicle. And my first week in there working with Chris, I don't know what it was with the code, but I went, and was looking through the code and looking at the paper, like reading the code and reading the paper for what it was we were supposed to do, because I needed to understand it, right? And I talk about due diligence all the time because I need to understand what it is that I'm doing. So I'm reading the paper, I'm looking at the code, and something was off, and I brought it to Chris's attention, and he was like, yep, you're right. I think we were double counting, like a subtraction. We're doing something multiple times. And once that was fixed, it started to converge and we were able to get results. And I remember he sent an email to my manager. He was like, oh yeah, Wendy deserves a promotion. She already found a mistake with the code. But that was very, very inspiring. That was very amazing to me that I was given credit for something that I had found, and it reinforced that it's not a waste of time to spend the time figuring things out, right? Because you don't know what you're going to find, and it also will help your own understanding. So I just kind of want to put that out there. Sometimes, again, it feels like there isn't enough time to take a step back, but taking a step back can actually save you time. So shout out to Chris and the Lucky Martin Skunkworks team for the cool work that I got to do. So that was the last year of grad school. Then I graduated. I had to put this picture up. This is not from graduation. This is from a convocation talk I did at UT a couple of years ago. But I'm doing the Mavericks sign because people ask me like, what is that? I'm like, oh, it's the Mavericks, like the UT Arlington Mavericks. So I graduated May 2015. Took some time off. I was going to work at Lockheed, and then I was going to work at somewhere else. And I, I had a couple of offers, but I really just chilled because I told you all these things about why, my PhD was pretty intense. And, I finished. I didn't want to even see a paper, write a paper, read a paper. I didn't want to do any research. I just needed to reset and breathe. And I've had people ask me, were you scared about not working, for that long? Yeah, a little, but I needed to breathe because there's this fear that, the longer you stay out of school or a job, the less employable. Right, that could be true. But I think about the opposite, because if I don't get that time to reset, if I don't take that break, then I'm not my full self at whatever it is that I'm doing, right? If I don't take that, take your vacation. If it's a month you have, don't feel bad if you need to take that month off. Just take that time and spend that time doing what it is you need to do. If it's 6 months of maternity leave that you have, take the 6 months and don't feel bad, because you come back even better. You come back hungry. You come back ready, like to just like a blitzkrieg. So I took some time off. So when I started at NASA in 2016, I was very well rested, recovered, that I just, I was so excited to do everything and jump into projects and be really, really, really hands-on. So at NASA, I am with the Intelligence Systems Division in the Exploration Technology Directorate. So the work we do is aero-focused in space. We're not just aero people. We can do it all. So in the Intelligence Systems Division, there's a Diagnostics and Prognostics group. And I want to say, I want to say this year, I talked about how my internship at Lockheed Martin, I knew the recruiters and I knew people, and I didn't even have to interview. At NASA, I didn't know anyone. I literally just applied like everyone else. And that's no one said, oh, I know her, so we'll hire her. No, I just applied and got a job as a civil servant and that's AIM. So it's not when I tell people to apply for things, they think, oh yeah, I'm hiding some information. No, just apply and just keep applying. Go on usajobs.gov and apply and put yourself out there and just keep applying, and something could work out. That was my story. I want to reiterate that is possible. It's totally doable. So at Ames, I'm with the Intelligence Systems Division and the Diagnostics and Prognostics group, and we work in the science of failure, figuring out when something bad will happen by modeling or data-driven methods. And that's something bad could be for a component, a system, or a system of systems. So trying to predict when there will be an end of discharge of a battery. We drive our car batteries till we see an indicator till the car won't anymore, but can we tell exactly when, something bad will happen? And so, but I have a controls background, right? I have an aero controls background, like I said. So I'm in that group doing some of that work, but I always find myself on a controls related project. And so when I started, I was on a DMP, Diagnostics and Prognostics Group, fault health monitoring project, and I was also on a controls project. And this is a picture here from one of the papers on my first controls project at Ames, and this was the Learn to Fly effort. So it was an advanced technology development effort aimed at looking at the feasibility of real-time self-learning flight vehicles. So when you think about the current structure for design and flight, you design, you figure out the aerodynamics, do the flight testing, and then you go into operations, right? The goal of this is how can you replace the current iterative paradigm for these vehicles and reduce the typical ground and flight testing requirements by learning real-time aerodynamic modeling, adaptive control, and other disciplines. How do you merge all of those and learn to fly? So like you want to be able to drop a small vehicle, you want to be able to drop a UAV, kind of like birds teach their young to fly, right? I know, they just drop them. You want to be able to drop this this vehicle out of, say, a tree or wherever from another vehicle, and it's it starts out with only a rudimentary set of parameters. It doesn't know much about itself. And then you kind of use excitation inputs to like the nominal flight control commands, and these excitation inputs, kind of excite the vehicle's natural dynamic modes, and then you use that to get an idea of what the response is, and then you do some control with that, and then you now have a better idea of what that error model is based on the response, and now you can kind of change your B matrix for the control people here. And so basically it's this iterative loop that at the end you have a better idea of what this vehicle can do than what you started with. So what's pretty cool was a multi-center project with people and then a few of us at Ames. So I get to do that, and it was pretty exciting. The other thing I got to work on my first year too, I was working on this in tandem with the Learn to Fly project, was real-time safety monitoring of our national airspace. This is another project that I got to work on at Ames as well. And basically with this idea, you're trying to look at, for a sector or a region of the national airspace, can you kind of predict when something bad will happen in time? Like you're doing this kind of real-time monitoring such that if you can do this prediction of like, oh, there is predicted in 5 minutes with some uncertainty of this and that there will be a loss of separation between aircraft A and aircraft B in this sector. And so you have an idea of the health of that sector, that there's possibly going to be a loss of separation, a wake vortex encounter, a convective weather encounter, and knowing that, what do you do with that information, right? So you're monitoring, assessing, and then eventually you want to be able to mitigate real time. You want to do it early enough versus, the reactive measures that we are typically accustomed to with these things. And so that work lasted a couple years, and then morphed into the system-wide safety project for my group. So we spent a lot of time doing that, and then system-wide safety came along, and it's a similar idea, but now it's for unmanned air vehicles or air taxis, right? And you can kind of think about, along a flight path, along a flight plan, what are the things that could go wrong with a vehicle or a system of vehicles? So now you're not just looking at a component, but it's a system of systems, a system of vehicles, right? Including things like convective weather, loss of separation, and all of that. And so JG said this earlier, I lead a team on that project that develops, not just identifies the safety wrong, they develop techniques to monitor and assess. And, we're basically trying to predict these things that could go wrong with these emerging operations in our airspace, right? Such that we can be able to sit in our living rooms and order pizza and a drone. The UAV drops it for us in 10 minutes or so. That's where we're trying to go. So, but with all of these needs, we're really going to see this evolution of our airspace as we know it. It's going to be a little different. And we're trying to stay ahead of the curve with these mitigation and predictive and assessment capabilities that are being developed. So I'm a sub-project manager on the system-wide safety project, specifically focusing on the emerging operations side. There are multiple technical challenges, and I lead one of them, the TC2, which is emerging operations for UAV, UAM type air taxi operations as well. And then another controls project that I also got to work on, which was really, really fun, was an early career initiative that we applied for in 2017 or so, 2017, 2018. Was it 2017? My memory. Yeah, so we got to, NASA every year puts out this agency-wide call for the Space Technology Mission Directorate Early Career Initiative Award, and it's a budget of about $2.5 million to propose something that an early career team would conduct this research on for 2 years, 2 fully funded years of about $2.5 million. And so our proposal was to develop precision targeting methods for deployable injured vehicles, or a class of vehicles that, when you think about spacecraft, they typically have their form, like there's a rigid aeroshell that's, kind of fixed, and that's the form of that vehicle. And then, it's launched, and you can fix your control, your reaction control system. So there's rigid points on the vehicle. You have attachment points to fix things too. When you think about a pole, that's what it looked like. I showed you Orion on a few slides. You saw the fixed form. Well, deployable entry vehicles are a new class of vehicles. They don't have that rigid aeroshell per se with a fixed form that you can attach control effectors to, right? They deploy, and they deploy in very different ways. The one that we're working on deploys mechanically, like an umbrella. It literally deploys like an umbrella. So you can imagine this thing that's stowed, and then, during or before entry, it deploys, right? Comes out and deploys after like spin stabilization, and it has its form. How you control something that, has a kind of shape, it has a shape that changes, it's not a rigid shape thing. So that's the one we're working on, was the lifting nano adept vehicle that we modified, and I'll speak a bit about that. But there are others that deploy pneumatically, right? NASA has a few others, like HIAD, which is the hypersonic inflatable decelerator. HIAD, NASA, the government likes its acronyms. But there are different deployable entry vehicles, and the one we're working on was the lifting nano adept vehicle, and even adept is an acronym. So we worked on that, got to do some really, really exciting, very exciting work with that. In fact, one of the other early career team members was Dr. Tracy Kahn, who also went to UTA as well. She got her PhD from UTA and was at NASA Ames a couple of months after I started. Our Maverick story in the Bay Area, California. So she was, I led the controls team in that effort. It was a multi-center effort between Ames, Johnson Space Center, and external partners at UC Davis and the Johns Hopkins Applied Physics Lab. So the controls team was at Ames and APL, and I led the team on that to develop the controls techniques. And so we looked at using non-traditional methods. So when you think about traditional methods for spacecraft, you're thinking reaction control systems. Non-traditional methods are looking at things that are more traditional for aero vehicles, like flaps. So we looked at flaps to try to see if we could also use moving masses to control this vehicle. So that was a super fun project. We had $2.5 million, early career team to pretty much go crazy, and we did, and got to publish some really, really good papers, high visibility, got to go to headquarters to present some of this work. I also presented this work at Oxford at the International Planetary Probe Workshop, IPPW, a really small community of planetary exploration folks. And so they were looking for like some GNC people. I got to do that. I went to Oxford in summer 2019 to present some of that work as well. And then finally, I want to kind of show the video of this. Hopefully you can hear it and see it and everything comes across great. But this was our proposal video that we submitted. So to submit for this particular proposal, you have to write the proposal, and you also had to create a video saying what it is that you were going to do and introducing all the early career members of the team. And I like to show this video because it really just, reminds you that, you get a request for something, or you're doing something, and you really can think outside the box, and you can think about bringing what it is that you know and who you are to the things that you're asked to do, right? Because if everyone thought the same, if everyone looked the same, how boring would our world be? So I was asked to actually come up with a song for this video, and I struggled to come up with a song for a very small section of the video, because I kept thinking about who the judging panel would be, who the audience and the recipients would be, and I was trying to put myself in their shoes to think about what they would want to see, when I should have just thought the entire time about who I am, or what I know, and what songs I know, or what kind of work I can do. And that was eventually what I ended up doing. So if you hear a song that's familiar or unfamiliar to you, it was one of my favorite songs that summer. But I'm gonna go ahead and play this.
Brandon.
Oh, hey there.
Your entry vehicle landed in my cereal.
Oh, I'm sorry. I didn't mean for that to happen. We haven't figured out precision landing yet.
Oh,
Does a bunch of other cool stuff though. Let me show you.
ArcJet testing has shown that Adept can survive the high temperatures of re-entry, and we've shown that it can deploy successfully. The next step is to figure out a system that can enable precision landing.
Brandon, I've been looking at the problem and I think we can take Adept to the next TRL. Let me show you. Guidance and control during entry is critical for precision landing, so we will simulate 3 control systems in this extensible MDAO framework in order to deliver a functional GNC prototype and demonstrate you can achieve precision landing.
Let's call some experts.
Dr. Robinson, this is Sarah. I'm thrilled to be collaborating with technology.
Hello, this is Brianna Johnson at Johnson Space Center.
You in?
Absolutely, I'm excited to be the lead for the Flight Dynamics and Guidance team.
Again, this is Brandon. Your innovative system integration approach at APL is just what we need for our proposal. Are you in?
Hi, Wendy.
Hi, Sarah.
Would you like to be the controls lead for this project?
Of course, I'd be excited to apply my controls experience to a spaceflight mission, but who's going to design a mission?
I know just the person.
Huh.
Hi, Tracy.
Oh, hey, Sarah.
Would you like to be the mission design lead for the?
I have experience at Ames that'll help me make sure we have a successful concept. But who's going to do the aerothermal?
I think it should be Ben Nikaido.
Absolutely. I'd love to contribute to a future Mars mission.
Okay, so we'll apply our innovative project management approach.
Right. By using Agile for software development in the first year and critical path management for hardware in the second year.
We can definitely deliver a functional GNC prototype for Adept in 2 years.
Let's do this.
Kind of how it is. Heavy. Promise to sweat.
All right. Yeah, so that's one of my favorite videos ever. And I like to show it, and I hope you could see that I get to do some really fun, cool things at NASA, NASA Ames, and my trajectory from UTA to Ames has been interesting enough, possibly untraditional. You know, I'm an advocate of taking time off, doing what you love, and resetting and recovering, even if it's 30 minutes a day. And with that, that brings me to the end of my presentation. If you have any questions that I cannot answer here, you would love to connect with me, I put my Instagram and Twitter accounts on there, because a lot of times I put opportunities or internships or things that I come across on those pages as well. So feel free to connect with me on Instagram and Twitter, and those are my handles. Thank you so much.
Wendy, thank you for that great presentation. I think we're going to be adding to your award listing pretty soon, Oscar, for that acting that you did in that video. So we'll see that one pretty soon.
Okay.
No, fantastic. Thank you for that information and overview on your journey. And I think we have a few questions here that I'll read off, and you could help answer for us. First one is, can you tell us what the name is of the program that you talked about, the one with Lockheed Martin, where you were able to connect with different people?
It is the Monster Diversity Leadership Program, and this was in 2007, so it may or may not exist anymore.
Okay. The second is about your LinkedIn. I think we can probably, what is your LinkedIn page? And I think we can share that in the chat, and you also just mentioned it.
Yeah, yes, of course. There's another Wendy Okolo, which is actually why I became Dr. Wendy Akolo. So if you find anything about me online that's a social media presence or a LinkedIn page, it should typically have in the bio Dr. Wendy Akolo. So yeah, I would just do LinkedIn Wendy Okolo and Dr. Wendy Akolo and see what comes up, or you can put it in the chat, JG.
I think Tracy's already helping me do that, so fantastic.
Awesome.
The next one is, how did you try to make the most of your internships during the summertime?
Yeah, so I'm a huge proponent of being you. People can see through, you know, a lot of fakeness. People can really, I think people can see it, right? So I would just say, be you, do the things that you enjoy. As an intern, I enjoyed spending time with the other interns and learning, you know, who was doing what, who was struggling with what. Was I the only one having these experiences, or was I the only one finding it difficult to be waking up at what 6:30 a.m. every day? Like, what is this? You know, as a student, we didn't have to do that. So I liked to connect with like-minded people, and through that, then I'd kind of get to see what they were working on, and I was able to meet other people in their groups as well. And then if you like or gravitate towards somebody in particular, you can get to know that person, ask questions of them, listen, try to, it's hard, I know it's hard to be attentive during meetings when you're a student, but do your very best to pay attention and take notes. Take notes, ask questions, be attentive, and just be authentic. I really want to hammer that. Please just be as authentic as possible, because people can always tell if you're not being you or if you're being fake or unreal, I'd say.
I think that's great advice. Another is what you do at Ames, is this kind of like validation and verification of subsystems?
Is this kind of like?
I think they're asking if it's like a verification of subsystems.
I do a number of things at Ames, depending on the work or the project per se. The controls work is not a verification and validation of subsystems, it's controls design. So you're actually saying you have a model, an idea of what the vehicle is. So you start out with the vehicle, you get the aerodynamics information from an aerodynamicist, and then you say you want the vehicle to follow commanded guidance trajectory. Basically, you want your vehicle to achieve something. And I sit in the middle of knowing what I know about this vehicle. How do I get it to do what I want it to do? Yeah, so verification and validation, you can kind of think about, oh, it's more like the design problem, and then you're verifying and validating that what you have or what you figured out is actually true. It is actually a true representation of that vehicle. So I sit in the middle of making things do what I want them to do, or figuring out when something bad will happen with something.
Absolutely. Another question is, how has your work kind of changed now given the kind of remote environment?
Yeah, it hasn't changed too much, because I'm not an experimental, you know, aerospace engineer. I don't work with wind tunnels, or I don't really have to do any experimental design or testing. For as long as I've started, you know, independent work, independent research, I could do my work from anywhere in the world. And that was even as a graduate student, right? I worked very heavily with MATLAB and Simulink, and all I needed to do was pull up my computer, open my laptop, and do some work. So in terms of the work, my actual work that I do, it hasn't changed too much. With meetings, you know, because no matter who you are, when you start working in the real world, you have to deal with meetings. Meetings have definitely changed, right? Everything is now virtual. I mean, look at this virtual brown bag seminar they were having.
Right.
And yeah, but the good thing about things being virtual is there is more access. So people that normally couldn't have attended something now have that access to attend from anywhere. That's one. And two, even when they don't have that access, it's recorded and they can refer to it, you know, at their own convenience. So now I'm having records, right? Records of things that I've done, or records of things that I do. This is going to be a video that's recorded and will be shared and disseminated. And I will have a record of that, you know, so I can share that with people, or I can post it myself, or, you know, things like that. So it's changed a little in that, you know, you're not having these in-person type events and meetings anymore, but in terms of the actual work I do, not so much of a change.
Perfect. Another question is, you talked a little bit about drones and the delivery of pizza to our homes. About how far away do you think that is from being a reality for everyone?
I think in terms of the actual technology and development, we're pretty close. But the regulation is another piece, right? And how do we allow, how do we enable, how do we facilitate? You have things like privacy concerns, right? A UAV flying over your backyard to deliver pizza to your neighbor is most likely going to be a problem for you. So how do we, kind of facilitate? So it's a very, very broad problem, and the FAA, for as long as this has been in discussion, has been looking for input, has been looking for solutions, and they're starting to put out ConOps, right? Different concepts of operations for these types of, emerging operations that are open and available to the public, just a simple Google search. So the technology is there. The only one technology challenge that I, can really say could be limited is in electric propulsions, right? Batteries don't have enough power for these things to fly very long, but oh yeah, it's there, it happens. And it's just, I would say the regulations piece is more the heavy, trickier to navigate challenge.
Absolutely. Another question is, what's your favorite part of your PhD journey and what kept you going?
Ooh, deep. My favorite part of my PhD journey. Oh my goodness, this is hard. There were so many highs. There were so many highs, and I will speak to, I'll speak to a few. So setting like certain awards and certain recognition and fellowships for me was more than the award or the money. For me, it was a validation that the work that I was doing was important, that I mattered, my work mattered, and my work was on par, with the most proficient, prolific, brilliant graduate student researchers around the world. For example, the Miller Earhart Fellowship is given to, at that time I got it, was 35 women around the world pursuing PhDs and aerospace related degrees. 35 women around the world. 35 women, and one of those 30 in 2012. And that was a big deal. That was a really, really, really big deal to me. So each time something like that happens, I also got the NDSCG fellowship. I was the first one at UT to have gotten that. But when things like that happen, it tells me, okay, Wendy, this is good. You're on the right track, because if all these like esteemed panel of judges think that what you're doing is relevant and your work is relevant and you're capable of this, okay, we can do this, right? We can do this. So for me, it was more than the money and the prestige. It was just that kind of that validation, that reminder that I mattered, my work mattered, and I could do it.
Absolutely.
Yeah.
Another question is, what are you most excited about for the future of space technology?
Most excited about for the future of space technology? A couple. So the Mars helicopter is preparing to take off anytime now. Maybe it has. It's supposed to be 10 a.m. Pacific, right? Yeah, so maybe it has, I don't know. And it has a piece from the wing of the Wright brothers' original flyer.
Oh, wow.
And it's just mind-blowing that we are about to have powered flight on another planet with a piece of, I mean, we're what? Like we're about to have powered flight on another planet. There's so much to explore. There's so much to that. And I, when or like Dragonfly, for example, I started getting ideas when the Dragonfly project got awarded. I met the PI in Oxford, actually, at IPPW in 2019. When I met her and I heard her talk and met someone else on the team, I started getting all these ideas about how can I get on idea? You just, and that's what research is too. You get these exciting curiosity and ideas and understanding how the aerodynamics, the atmosphere on another planet, what is subjected to what with everything that we know now, how does that change? And it's just exponential, the amount of learning and information and data that we're going to start to get and start to play. Some of the work that I talked about with guidance and control of the deployable entry vehicle, right? These space vehicles are changing, and the things that we typically used to lean on in the past, we did have the most brilliance. I mean, look at the Hidden Figures, right? I don't know if a lot of people have seen the movie, but if you read the book, it really, really speaks to how much these women did with less. how much these people did with less. And so sometimes we get comfortable, but people did so much more with less. And now we're having all of these opportunities and all of this data to explore and develop even more very interesting patterns. So there's a lot of exciting stuff going on. But again, you see that I'll still always throw in the aero, right? I talked about the UAV flying on Mars. It's not just about space for me. For me, it's aero. It is aerospace.
Absolutely. And then Wendy, last question we have for you is, we know you're a relatively new mom. Could you talk a little bit about work-life balance, and somebody who's so esteemed as yourself and doing so much work, what does that look like for you?
Work-life balance, what is that? I'm kidding. No. So for me, it's, you know, waking up early, dealing with my baby, passing him off to grandma or his dad, going for a 30-minute run, because if it does not happen in that morning, it's not happening. Coming back, playing with him a little, because I work Pacific hours, and then starting my work day. But what I found that works for me very, very well with having a child is structure. My boy is like clockwork, sleeps, goes to bed at the same time, takes his naps as scheduled. And so I can actually plan. I can plan. We're able to do stuff because he has a schedule that works very, very well. I also have a very supportive husband, and he just has my back. I mean, I can't imagine all the things that are on my to-do list that I don't even realize are on my to-do list till he takes care of them. And he's an engineer too, but he's so much more in his time than I am. But having a really, really, really good schedule for my son has helped. At 7 p.m. he's out, he's asleep, and so we can do some things, decompress. I can work as I should not, but having a good schedule and getting that exercise in first thing in the morning is great.
Fantastic, and thank you for that, Wendy. And Wendy, I really appreciate your insight and sharing today about your journey, and also thank you for representing UTA Engineering so very well. We're very proud of you and glad to have you as one of our alum.
Thank you so much. And fun fact, I'm going to be doing a panel with Dr. Lori Glaze, UTA too, that's very prolific for the Girl Scouts in about a week or so. So I'm excited about that too. There's UTA everywhere. UTA alum just doing big things everywhere. So yeah, Lori Glaze is a big deal. I'm excited about being with her in that panel. So thank you as always for having me, UTA, the College of Engineering, and thank you for your time, JG. I appreciate it. Thanks for all the great questions too.
That's our audience. And to our audience, please join us next week as students from the Electrical Engineering Department will have a student takeover to talk about their experiences and what they're doing with current research activities. Until then, thank you. Have a great weekend. And again, thank you, Wendy. Have a great weekend.
Bye-bye.
Bye.